All right, all right, all right. Today is about working on our gamer ICC profile generator. Again, I play video games. Sometimes I'm like, they're too dark. I want to make them not too dark. Wowza! Um, and so we've been making this GUI program that is supposed to basically generate color correction profiles that will make it so that basically the GPU thinks that it needs to adjust for display inaccuracies, but really what it's doing is like cranking brightness or adjusting gamma, increasing digital vibrance, stuff like that. And so what I want to do today is I want to clean up parts of this GUI app, kind of look like all of the code in here is like shit, so I have to fix that. And also the profiles that are generated do not match the what we are seeing in this like preview that we see here, so we have to figure out what's going on there. And probably if we get through that, I'll be pretty happy for the day. We might not even make it through there depending on how complicated it is to get all this to work right. But yeah, so basically like what's being generated, I believe, is like something that goes through a 3x3 matrix followed by like red, green, blue tone curve adjustments, I think. Let's just double check this. I see profile spec. So the way these things work is they kind of like act in general PCS space, they call it, which I believe is profile connection space. And coming out of this profile connection space to device space, they go through this set of transformations. So they take the inverse of the 3x3 matrix you give it, and then they take the inverse of the tone curves you give it. So we right now are trying to apply gamma by saying like adjusting the inverse of this curve to match what we want it to look like. And this matrix we know is wrong right now because profile connection space is in this like French 1931 format called CIE-XYZ or something, where it's kind of like Y is approximately luminance, Z is approximately blue, and X is approximately like a red-green selector, kind of. I guess like, yeah, red-green null selector maybe, I guess, is probably what this guy actually has to be. So this matrix like transforms it to RGB space and also like does like white point adjustment and stuff. I believe what we've seen in other profile. How are the changes? Are you making this app also going to be using the game? You don't have to code for it. They're not using the game. They're using the display pipeline. So what this ends up doing is it programs this 3x3 matrix onto the GPU as well as these tone curves in like really cheap lookup tables on like kind of like the outputs thing. So like your game, like game. He is going to do a bunch of stuff, but eventually it's going to end up in some like GPU frame buffer somewhere, right? This gets like forwarded to maybe the like display server, like KWin. And KWin might just pass this directly to the GPU if it's in full screen mode. If it's in windowed mode, it might like composite it with other stuff. This is like another GPU buffer, I guess. This GPU buffer then goes through some transformations, and that's where this stuff gets applied. So this is kind of like this like really late in the pipeline, right before it goes out to my display, right? So like kind of like right here is where the changes get made, right? Ish. So yeah, right now we generate a profile and we reload it with MPV and it doesn't look right. So I think the first thing I want to do is make sure that this matrix is correct, which I don't actually know if we've read the official spec on what that matrix is supposed to be. So can we look at that? Can we look at that? What is it called? What is it called? That matrix is called RXYZ, kinda. Red matrix column tag, which is used in the matrix TRC transforms. Okay, that's not helpful. This column multiply with the linear red channel during matrix multiplication. Yeah, matrix. Like, do they explain that thing anywhere? The matrix tone reproduction curve model is explained in detail in 8.3.3 and 8.4.3. Okay, 8.3.3. A three-component matrix input profile should contain the following tags. So this is the matrix. These are the curves. The A to B tag, blah 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 blah, may also be included, but they are not in ours. Only the PCS XYZ encoding can be used in the matrix TRC models. This profile may be used for any device which has a three-component color space suitably related to this by this model. Cool. That's not helpful. Three-component matrix-based display profiles. The computational model supported by three-component this shall be defined in F3. Is F an annex? Yeah, here we go. The model describes transformation from device color space to profile connection space. The transformation is based on three non-interdependent per-channel tone reproduction curves to convert between non-linear and linear RGB values in a 3x3 matrix to convert from the linear RGB values and relative XYZ values. Yes. So the mathematical model is this. So when we're going from connection to linear space, we apply this matrix. Cool. What are these supposed to be, though? Can you use the GPU for the map multiplication, or does it have to be done on CPU? I mean, in this case, it's one, like, every pixel on the screen is going to do this matrix multiplication on GPU, if that makes sense. But we need to, like, pre-matrix we need to, like, generate this matrix, which is done on CPU. Okay. Like a shader thing? Like, kind of, like, more specific and efficient than a shader thing. But yeah, very similar. Okay. If the red jersey, blah, 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 not what I'm looking for. I want to know what this is supposed to be. Like, I guess we want to look up, like, sRGB to PCS XYZ. So what we saw when we were experimenting with this was that we inferred that the matrix was supposed to be one, sRGB to XYZ space, but also white point conversion. But I don't know if I can, like, if I see that anywhere in here. Can we look up maybe, what do they call this? Three-component matrix-based profiles. I'm down to ask the idiot. SGB image probably gives you non-linear sRGB values, which are fed to your shader. Oh, good point. Good point. I mean, we need to fix this either way, but you're right. Okay, so, like, places we could be wrong. Places we could be wrong. Image loading, linear or sRGB. Texture output, linear or sRGB. We have the, like, color transfer matrix, guaranteed wrong right now. What else on top of, probably, like, curve application, like, gamma in linear to curve lookup may be wrong. Can I just look? I'm just gonna ask the idiot. In ICC profiles, we have, I am using the three component lookup, the setup. 3 tone reproduction curves and a 3 matrix. What is supposed to be it? Is this matrix supposed to be the transformation? I mean, I guess we know that it's supposed to be. Never mind. I can actually, now that I'm asking the question, it's clear. They're saying that this matrix is supposed to convert into the PCS XYZ space, which has a given white point. So we know this. So what I really wanted to look up was D65 to D50 white point matrix. Because I think that I read somewhere that this is not supposed to be a linear, it's not supposed to be like a scale matrix. What's this guy talking about? This guy seems like he's kind of talking about exactly what I want. uh yeah, yep. So Bradford transformation matrix. This is what I've heard something about this before. Okay, can we read this top to bottom maybe? This actually seems useful. This page provides a step-by-step worked example performing a Bradford chromatic adaptation to calculate the D50 adapted ICC sRGB profile, red, green, and blue primaries from unadapted red, green, and blue and white XYZ values given in the sRGB color space spec. This is exactly what I'm looking for. Okay. So, the ICC sRGB profile is made as follows. The unadapted red, green, blue XYZ values are calculated from the unadapted red, green, and blue XYZ values plus the D65 source white point XYZ values given in the sRGB spec. The unadapted red, green, and blue XYZ values are chromatically adapted. What the fuck does that mean? From the D65 source white point to the ICC D50's desk white point using Bradford transformation matrix. So we can just look this up, right? There's probably a Python library there for this. I don't know what this is. Thank you. Okay. Transformation matrix. This is a spectrally sharpened transformation matrix, i.e. the L and M cone, which is red and green cones. Where were we? Response curves are narrower and more distinct from each other. Bradford transformation matrix was supposed to work in conjunction with modified von Kries transform method, which introduced a small nonlinearity in the blue channel. Okay, so he takes XYZ, and this creates RGB. And then which way are we going? We're going... I mean, do we want the inverse of that matrix? Hold on. So when we are going... This is supposed to be going from RGB to XYZ. Yes, so we want the inverse of this probably somewhere. How do I want to do this? We have some sample profiles, which we believe should somewhat follow... how do I say this? Should somewhat follow sRGB. So if we can reconstruct their matrix manually, we'll be in a pretty good spot. So can we just kind of say like these are G, these are B, G, G, B, B, and then we have to make these functions. So G goes to G, and B goes to B. Okay, and then we print our matrix, so we have kind of like this, I guess, which is gonna have R XYZ X G X and BX. And then we do the same for Y and Z. Okay. Okay. Zig run, ICC reader. And can we look at like our sRGB 1.0 gamma? Okay. All right. So this is a matrix that we see somewhere. Can we limit the decimals so that everything lines up? What is it? Oh, fuck. We need to look up the format. Fill alignment width. Dot precision. Is it like this? Oh, yeah, that's what I want. All right. So this is the matrix that we see in our sRGB profiles. And so we need to reconstruct this thing. So we know that we have sRGB on Wikipedia defines a matrix that does not look like this that we saw last time, right? We saw this guy, which is not this guy. They're different. But this is after we have RGB, right? So this guy's saying that we need to combine with like Bradford or something, is what this guy somewhere said. So Bradford converts from XYZ to RGB. What the fuck does this mean? Okay. Is used in conjunction with the linear. What does this mean? I don't understand what this means. Let's keep reading this guy. The rest of the page walks you step by step through the mathematics of calculating the ICC D50 adapted sRGB red, green, blue, XYZ primaries from the values given in the D65 color space spec. All the calculations are in the downloadable this spreadsheet. Okay. sRGB specs give values for the sRGB unadapted red, green, and blue XY values in the sRGB D65 source waypoint. So this is what red is, this is what green is, and this is what blue is with this white point. So that should match something here, right? 0.79. So 0.64, 0.33, 0.03. That looks nothing like this. But it does look like this. No. X, Y, Z values. Oh, yeah. 0.64, 0.33, 0.21. This is not the same. Why is this different? Like, what? Why does he get different numbers for this? This looks wrong to me compared to this. How's the ICC thing looking? It looks like it's possible. I'm a little bit confused about this matrix, though. sRGB standard defines the chromaticities of red, green, and blue primaries. The colors where one of the three channels is non-zero and the other two are zero. The gamut of the chromaticities can be represented with the color triangle, which are set such that the range of colors inside the triangle is well within the range of colors visible to the human with normal trichromatic vision. As with any color space for non-negative values of RG and B, it is not possible to represent colors outside the triangle. True. The primaries come from HGTV, which are somewhat different from those from other color TV systems. These values are chosen to reflect the approximate color of consumer CRT phosphors at the time of its design. True. Flat panel displays were generally designed to emulate CRTs. The values were also reflected prevailing practice for other displays as well. True. The sRGB standard specifies also the colors and relative intensities of three primaries by defining the mapping between these values in linear brightness scale before the gamma coding, and the perceptual color coordinates. This mapping is the same specified by this standard. Okay, in particular, the second row of this matrix specifies the computation of the luminance value from the linear primaries, blah, blah, blah. And this is the inverse. The 1999 standard provides the matrix this, which is the exact inverse to 4 decimal blah blah blah. Yep, okay. We amended this here and changed them to just add more digits, which is sufficiently accurate for 60-bit samples. And for these formulas, XYZ values must be scaled so that the Y of D65 white is 1.0. This is usually true, but some color spaces use 100 or other values. Okay. Okay. So I guess this is all talking about linear sRGB to XYZ with D65 white point. Because the XYZ space is like perceptual or something. So like if I view the most red thing ever under a D65 white source, it's going to look different. It's like it triggers my eyes differently than the most red thing in a D50 white source or something. I never quite got this. To me, it seems reasonable that as soon as you're given RGB values relative to a given white point, they are adapted to that white point. Here we're given a white point and told that the accompanied RGB's values are unadapted. Triggers your brain differently. Yes, true. Sorry, my eyes triggered the same because the XYZ values should be directly correlated to my eyeball's response, but not to my brain's response, because my brain's doing auto white balance, essentially, all the time. Yeah, what does the adapted even mean? Adapted isn't in this Wikipedia page at all. But in this guy's page, he's talking about unadapted red, green, and blue. Okay. Can we ask the idiot? So some page on the internet is giving me the above, but on Wikipedia, I see this. Why are they so different? They're not contradictory. They're showing different but related chromaticity XYZ values using different conventions. This guy's saying he's unadapted. Okay, first of all, we never trust this guy, right? Reminder, never trust this fucking idiot. So he's using unadapted, but he's claiming that they're using unadapted as full XYZ triplets. Normalized, so XYZ equals 1. Those triplets are actual trisymmetry values in XYZ space. He's claiming that the Wikipedia table is giving chromaticity coordinates and a separate Y luminance scaling for the primaries. X and Y are actually 2D chromaticity coordinates. Let's look at that again. Oh, yeah, this is X, Y, Y. No, he's right. He's right. Given X, Y, Y, you can recover X, Y, Z by X equals X over Y times Y, big Y, and Z equals 1 minus X, Y. Yeah, got it. Okay, sure. So they're both right. So then, this matrix does not correlate with this at all, but we'll see if this guy gets the same one at the end. Let's keep reading this guy's thing. If you do some adding and subtracting, you'll find that the Z values are always equal to 1 minus X minus Y, so the Z values don't add any new info. The real question is what are the right sRGB, unadapted red, green, and blue, and source white point Y values? Is this true? Yes, I see. Okay. Is that always true? Surely not, right? Surely not. Okay. The Y value for D65 is automatically 1 because RGB color space white points by definition are normalized to have a relative luminance of 1.0. For analysis with stone, how to calculate sRGB unadapted red, green, blue, and Y values. Okay, cool. So then he says, to make an actual ICC profile from the XYY values given from the sRGB specs, the unadapted XYY values must be chromatically adapted from D65 to the ICC D50 profile test. White point, better known as D50 luminant, sure. They give us the exact values. So PCS adopted white chromacity should be the chromaticity of the D50 luminant defined here. And sure, they talk about these numbers again. Cool. So table 2A gives the sRGB source and dest white points that we'll use to calculate sRGB D65 to D50 Bradford chromatic adaptation matrix. Okay, cool. So he's got this thing, and ICC is in a okay. So this is XYY. This is XYZ. So we need to like somehow convert between these different coordinate systems. Chromatic adaptation calculations are done using XYZ values rather than XYY values. So calculating the sRGB D65 to ICC D50 Bradford chromatic adaptation matrix requires converting. Yes. So then they have this, and they say it's fucking simple. When they show us what ChatGPT showed us. So now in XYZ space, we have both. Boom. Sick. You'll see that maintaining 4 decimal places of accuracy for values initially specified by XYY values requires considerably more than 4 decimal places in the XYZ values. Same is true the other way around. Okay. Cool. So he's got these bad boys. Then they talk about the Bradford transformation matrix. So the matrix needs to define the cone response domain transformation. Many have been proposed. So I guess this is kind of saying like there is a linear transformation of what I saw red under one light versus what I saw red under the other light, but it is not just like a linear scale on each cone probably. Right? So this is kind of saying like, yo, what is this matrix? It's one of the many mathematical transformations that have been suggested for converting XYZ to an LMS color space that describes the response of 3 types of cones of the human eye named after their responsivity at long, medium, and short wavelengths. It is used to calculate Bradford chromatic adaptation matrices. The table 3 is used to calculate Bradford chromatic adaptation matrices. So this is not the adaptation matrix. This is something that we use to calculate the adaptation matrix. Okay, so the sRGB color space doesn't define how to convert to D50. This is not surprising because it describes the ideal CRT monitor unrelated to ICC profiles. However, ICC recommends using Bradford adaptation, and that's what all of these guys do. So, okay, here we go. So here he's saying they calculate using this, but like how? So Bradford chromatic adaptation matrix. The source and destination white point cells are already pre-filled in with the D65 source and white point, the D50 calculation white point to calculate this, blah, blah, blah. They produce this. Okay, can we go back to the Bradford thing? MBFD. This is a spectrally sharpened transformation matrix. So this is used in conjunction with this method, explicitly so in ICC profiles. They don't talk about. Okay, so this guy says, yo, Bradford transformation matrix looks like this. So this is the same numbers here. And he's saying you use this to generate the chromatic adaptation matrix, which also I think is in the spec for ICC somewhere. Chromatic adaptation tag. The first part recommends a chromatic adaptation transform for general use. The second part provides a mathematical description of this recommended chromatic adaptation transform. The last part provides basic guidelines and instructions for use of the tag. The tag is required in order to allow measurement values relative to the adopted white chromaticities, different from the PCS adopted white point, to be calculated from the profile data. Such values are not needed in the normal application of ICC color management. Why? See 6.3.1. Why? The PCS adopted white point chromaticity should be this. Okay. Well, that's confusing. Chromatic adaptation. This tag contains a matrix which will be invertible, which converts an XYZ color measured using the additional illumination conditions and relative to the actual adopted white to this. The tag reflects a survey of currently used methods of conversion, all of which can be formulated as a matrix transformation. The Bradford transform is recommended for ICC profiles. Okay, so what they're saying, it's not usually needed, but also you need it? I'm confused. But it's okay. So they're starting in XYZ values in the actual device viewing condition, and this is chromatically adapted. I remember seeing something about like chromatically adapted being ignored somewhere. Here. No, not this one. Blah, 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 blah. Okay. Describes colorimetry of actual originals and reproductions. Blah, blah, blah. Okay, that's not what I'm looking for, I don't think. Transformations for the IC absolute colorimetric intent shall leave the chromatically adapted stimulus values unchanged. 6.3.1 seems to be saying D50 is what your data is probably relative to always. That may be true for film environment, but not in PC environment. Maybe the spec assumes is primarily written for film. Maybe. Yeah, it could be. Let's read that again. The PCS adopted white chromaticity shall be the chromaticity of the D50 luminant defined in this ISO spec. Oh, sorry, this is the definition of profile connection space. So they're saying in 6.3.1, profile connection space uses D50. Okay, we don't have to worry about that. Yeah, so my measurements might not have used D50, but when we're in like this mathematical space where everybody can connect to each other, everyone should be using D50 there. Okay. Understood. Okay, one thing I also wanted to check here. I wanted to see if this thing even has, like, if the profiles that we have examples of have this chromaticity tag thing. That will be a clue on if we should have it, I think. So how does this work? On tag table iter, they iterate this thing, and here can we just say like tag this guy. So what is the chromatic adaptation, or Annex G maybe? Tells us like the definitions of things. So we have this guy, chromatic adaptation tag, which should have a signature somewhere. Chad, right? So no Chad in here, right? I don't see the word Chad anywhere. And then let's check another profile. So we have this sample IC profiles, null. No Chad there. No Chad here, right? So these guys are not using this thing, but they are using the, which I guess explains why their color transform is going in, their like white point transformation is going in these. That sounds right as well. Okay, maybe I want to go and I want to ask the idiot about the Bradford transformation matrix. Can I just ask him this? What's this guy talking about? How would I generate a adaptation matrix from this then? Maybe he will explain. He says he's entering 2 steps: a linear transformation that maps XYZ into an LMS-like space, the Bradford matrix, and a chromatic adaptation which scales LMS to account for different white points, and then maps back to XYZ. It's an XYZ to LMS basis. I see. So we go, they're going XYZ to LMS. They invert the matrix. They convert the white points to LMS. So they slap these through the matrix, both white points. Didn't the post link a spreadsheet? Yeah, but I didn't want to open it. So then they do, clever. So he's saying you just do the white point like you can do the linear transformation for the white point in LMS space, but not in XYZ space, which makes sense. So, okay, where LMS is kind of like triggering of my cones. So, does he get the, like, we'll trust him a little bit, but not a lot. Okay. So can we try what the idiot is outlining? And we'll see if we agree with him. So test 3 pi. Okay, so in here we have this Bradford matrix. One of these bad boys. So we have 0.8951, 0.2664, now 0.1614. Then we got negative 7502. We got 1.7135. And we got 0367. Then we got 0389. We got negative 0685. 1.0296. Okay, so the claim here is that we start with the 2 white points. So we have D65 white is this. And then we have D50 white is this. Okay. So the claim here is we go D65 LMS is going to be D65 white multiplied by Bradford. And D50 LMS is like this. Then we should be able to do, you do like some sort of scale here. So, also, how do you like numpy invert matrix? That's why I do this. Bradford inv is NP Lionel G inverse of Bradford. Okay, so they're saying we make a matrix of D50 LMS out of D65. I guess you can just do this, I guess. Python 3 test 3 pi. I guess we need to Python 3 packages pillow and Python 3 packages numpy or something. What do you call it? Inv, not inverse. Oopsies. LMX should be LMS. Okay. So then we have, this looks like a matrix that could be right. Can we also maybe print D65 white and D50 white? Or LMS, I guess, is what I want. Okay, cool. Cool. And then the idiot says we multiply these things together. So we say we have kind of like scale mat is this guy. And so we kind of want to do like Bradford inv scale mat Bradford. Right? So we take in a color, we convert it to an LMS, we scale them, and then we convert them back. And supposedly this should be close to what this guy finds. Which it is, right? We see the same numbers here. Perfect. Okay, so we understand up to this. Chromatic adaptation is done using the XYZ values, and the sRGB specifications provide XYZ values. But this is like lowercase and uppercase. Maybe that's relevant. Oh, he probably meant to write XYY here. Right? RGB color space white points are normalized to 1.0, and the sRGB D65 white point Y is automatically 1.0. I'll show you the math for calculating the sRGB unadapted red, green, and blue Y values, which can be found in this. Beautiful. Assume for the moment that the unadapted RGB Y values are also equal to 1.0. Producing interim red, green, and blue XYY values. Okay. Then he calculates XYZ from these things. The first step is to treat, then he's like, to calculate the real values. First step is to treat the XYZ values in table 5b as a 3x3 matrix and calculate its inverse. Jesus Christ. Second step is to turn sRGB D65 source white point XYZ values from table 2b into a 1x3 matrix. Jesus Christ. He's like, this seems more like math and magic. That's funny. So get fucked. Jesus Christ. Jesus Christ. So then, I mean, can we just like use this matrix? Is that the answer? Okay. Well, no, because, okay. Maybe we can just use this. Let's read a little bit more though. Because I feel like we understood up to the chromaticity part. First of all, wait, let's just check also. Can we just like read again? 436, 385, 143, 022, 071, 061-ish, 014-ish, 097, 714. Okay, we can just use this matrix. This is just the matrix that we're seeing here, and he's calculated all the way. So I guess we'll just use this. That's the, instead of trying to understand, what if we just didn't try to understand? What if we just did this? Because I don't want to deal with this shit. The easiest fix. Who needs to do math when you can just trust? And then eventually we're going to have to take this matrix and turn it into something. We're going to have to like add things to this matrix when we want to do our transformations, but this is a good starting place. Okay. Okay. Can we also start this gamma at 1.0? Better. Okay, so if I save this thing and open it with MPV now, let's see if we see something that looks the same. I think fixed. Obviously not, right? Obviously not. But what if we don't use this profile? That looks pretty similar, kind of raw. So our profile is definitely fucking shit up, obviously. Obviously. So why? Okay, so we should be exporting a perfect sRGB profile. Can we also like we can also compare with this sRGB 1.0G. Oopsies. Yeah, so now we are reproducing the same broken sRGB thing. So this is not ours, but our profile that we're generating looks a lot like this. And so the question is, why? Like, also, I want to also check, I want to check if I apply that thing to my desktop, does it do the same bullshit? I don't remember if we checked this already. You guys won't see this? I mean, that definitely changes something. I definitely see change compared to no ICC profile. So that's interesting. But yeah, my understanding, as of right now, which could very well be wrong, is that how do I say this? I thought the default of my computer was to assume a perfect sRGB output. That's what I thought. And that's not happening. So I kind of want to look at how MPV is generating the lookup table here. maybe we need to understand that a little better. Just a little bit better. Because otherwise, our preview won't match behavior there. Wait, let me try one more thing real quick. Open this thing with this, and then in here, change my ICC profile to match again. I want to see if it looks as fucked up as it did when we loaded it directly in MPV. I want to know. Yes, it does. Okay, so the good news is, I think that MPV and the desktop are doing the same thing. You guys didn't get to see that part, but it looked just as fucking black, which is super interesting. It means that what we think is like a no-hop profile is generating a lookup table that is making things darker, which is interesting. So can we go into the MPV source code and try to figure out, I guess the real thing to look at is he uses library like LCMS2, Little Color Management System. And somewhere we found he like generates a lookup table to that thing, but I don't remember where. Probably in here somewhere. Probably in here somewhere. So there's like GL LCMS get 3D lookup table. And in here, he calls this guy that says, hey, can you create me a transform that goes from the video profile to my profile? So he says, open profile from memory with our ICC profile. And then this guy internally is generating the transform. So I guess what I want to see is if we can reproduce, like just look at this transform data. So we could either do this in MPV right now, or we could try to pull out the LCMS stuff and try to generate our own. Because like this is where the interesting stuff is happening, right? What am I looking at here? So this is a 3D lookup table that he's generating. I wonder if you have like, he's calling CMS do transform. Output. What am I looking at? For blue, for green, for red. He is generating input, which is 3 times SR, which I guess is probably size of R, probably. Okay. And so then he's putting this into output plus base. So he's trying to do a CMS do transform. This is like a 1D transform, I think, at fixed red and blue and green values for each red. I think. Yeah. That seems like what's happening here. So maybe we look up this function. That's not helpful. Are there docs somewhere? Are there docs? Doc. API. Maybe I need to, can I just download this? Good night. I'm so curious. The app is for managing ICC profiles, or what is it? I cannot get to understand. We are trying to generate ICC profiles to trick our GPU into making games look the way we want them to. So maybe we want to increase brightness, contrast, apply some digital vibrance, adjust gamma curves. We want to basically lie about our monitor's calibration to make something behave the way we want, if that makes sense. All right. This function translates bitmaps according to the parameters set up when creating the color transform. Parameters. A handle to the transform object. Could this be caught by any cheat systems? No, and I don't even think it's cheating. I mean, it's really like more about like like it's the same as turning up the gamma on your monitor. I think that's the same. I think that's like totally fine. A pointer to the input bitmap, pointer to the output bitmap. Number of pixels to be transformed. Yeah, okay, so interesting. So this is supposed to transform a bitmap, and they're creating a lookup table by basically feeding in a bitmap of specific RGB values to this thing. That's what they're doing. And so I guess we want to understand why this is not a linear transform. That's kind of like where we have to figure this out. So to me, it seems easier. It seems easier to apply, like to just make one of these transforms ourselves and figure it out. So what does get vid profile do? Like, can we just get like an sRGB profile or something? I guess we also wanted to check if the image loaded by STP image is linear or not. We did have to check that, right? Yeah, we should probably do that. Because that changes things. Let's come back to this. So it's LCMS like table generation. So can we look up in STP image sRGB linear? No, that's not really. There is for loading files as linear floats to preserve full dynamic range. You load LGR images through these ranges. The image will be promoted with floating point values. Run through the inverse constants before. Okay. So likely. Can we make sure our like is our OpenGL buffer output buffer linear or sRGB? Like, how do I know? Normally sRGB images perform color correction, blah, blah, blah. Depends on the format of the buffer. Yeah, that makes sense. So what is the like default frame buffer? The format will tell you. Yeah, makes sense. GL default frame buffer sRGB. Can I check this? Blah blah blah. Can I like query the default frame buffer? Query frame buffer format or something. I think the default is linear and assumes no color management at all. That would be my assumption as well. No, this isn't what I'm looking for. OpenGL sRGB buffer. Looks like an extension. Oh, this is way too early though. Let's ask the idiot. Is the default OpenGL for frame buffer linear or sRGB? You request an sRGB default from the Windows system. So it depends. Can I query it? I can do this as well. Shader outputs are expected to be linear. Okay, so if... So then the question becomes, do we need to do some sort of like sRGB inverse if we're loading from this texture directly? Like, are we doing this wrong? If I'm rendering an image loaded with STB image in OpenGL, am I supposed to undo, like, apply an inverse sRGB curve to my texture? The answer, he's saying yes, which is interesting. 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 So in our thing, he is kind of claiming, which may or may not be true, that we should be doing something like this. That does not look right in the slightest, though. Hold on. Yeah, no fucking way. No fucking way is that right. And that there's no fucking way that matches. There's no way that matches this. Actually, maybe it does. Is this the same? No, you can see more in this than in this. Although it's funny that this is closer. I mean, I guess we're not doing like the proper inverse sRGB curve either. If you create the texture as sRGB alpha 8 texture calls in the shader, will do gamma correction on the data to linear return by function. Oh, that's kind of sick. That's kind of sick. So you're saying I should be able to, from, where do I make this texture? I think that I say like make texture from RGBA. And here you're saying I should be doing this. Here, when I create the texture. Because this is the format that I'm pulling in. And then... not quite. Not quite. When you write to the frame buffer attachment, it will do gamma correction from linear to nonlinear values if this returns sRGB8. Interesting. What the application is picking up, the buffer expects is not defined by OpenGL, but is probably sRGB. Ouch. Ouch. It's also fucking hard, man. It's also hard. If you create the texture as sRGB8 alpha texture calls in the shader, should match. When you write to a frame buffer attachment, it will do gamma correction from linear to nonlinear values. If this is true, the application picking up your buffer expects is not defined by OpenGL, but it's probably sRGB. But then probably like OpenGL is probably handling that for me. So I'm more interested in the fact of the input, my input texture, right? So can we look up like load sRGB image to OpenGL texture? You specify the internal format of the texture. So that is in... I guess this is the... That's the third one. Oh, this one. Is this true? So he calls sRGB and then says the input data is RGB. Interesting. Okay, let's try it. I mean, so confusing. So confusing. So like when I load this image normally with MPV, by default you get no sRGB awareness by OpenGL. This works out if the shader does only pass through texture data to shader values to frame buffers, sRGB, sRGB, sRGB. If the shader does anything interesting with expected linear values, that fails. That makes sense. That makes sense to me. So what I'm missing here is when I watch this video normally with MPV, it looks like a little bit visible at least, right? And does this match what it looks like when I open the video normally as well? Like, undo this, just load the image normally in my thing. Right? Like, does this look the same as this? Yes. These are the same fucking picture. So, both of these guys, when loading the thing with no profile, look normal. And as soon as I start trying to do anything, they start to fuck themselves up? I think I want to understand Sorry, my brain's like melting a little bit. Is it something like everything's untagged right now? And when I start trying to claim that this stuff is sRGB encoded, it like doesn't know to do the inverse or something? Yeah, I'm missing something here. So when I'm doing pass-through texture right now, it is likely that we're going sRGB start to end. STB image is loading this thing as sRGB. We put this in the what's image you get? In the texture. Texture passes out, copies the values directly, comes out the other side. We think that it is then presenting to the display as sRGB. And so you guys are saying, I need to GL enable GL frame buffer sRGB to output sRGB. But like, so in here, you're saying everything passes through by default. Then why do I need to enable sRGB? Like right now I've touched nothing. I've just kind of opened it the default way and shoved a texture in there, and it looks, as far as I can tell, correct. Actually, let's double check this. So this is what this PNG looks like if I open it in Gwen view. If I open it in MPV, hold on, does it look different? Oh my god, wait, this... Well, that's not good. I opened the same picture in two fucking image viewers and they look different. Why does it look different, man? Fuck. Can we compare with like Fe or something as well? Proving the point I said the other day, no one does this shit right. God damn it, dude. Isn't this like a real big problem? Okay. Okay, so this is MPV. MPV and FEH are doing the same thing. Gwenview doing the wrong thing seems more like... Can we open like GIMP or something as well? Oh. Well, GIMP's telling me something interesting. The image 091 PNG has an embedded color profile. Keep the image profile or convert. I guess they should show the same thing. Keep. Okay. So now it looks like what we saw in... This looks like what we saw in Gwenview. Now, Gwenview... No, those aren't the same either. Okay, let's open it in GIMP again, but hit the convert button. These things are close to the same. The one in Gwenview looks a little bit more faded. I would assume a browser would do the right thing. Yeah, let's try that, I guess. This looks like what MPV is doing. MPV and Firefox look the same. Okay. If you don't do sRGB linear sRGB, you will get incorrect blending when outputting to the frame buffer when doing bilinear interpolation on the texture sampling. Makes sense. Makes sense. Okay. Okay, so what does all this mean? It means that I feel like I trust if MPV, and Firefox are all showing the same thing. I feel like I trust that most. I'm opening Chromium as well. Holy moly. I guess also this image was generated with MPV, extracting, or with FFmpeg, extracting frames from a video, which I don't know what that means. Chromium. Great. Great. Maybe at Nick's, maybe in a fresh Nick shell, maybe there was something conflicting there. Chromium. Yeah, there we go. Chromium samples 091. Okay, so does this look like... Oh no, Chromium and Firefox don't look the same, man. I'm gonna lose my fucking mind. I'm gonna lose my goddamn fucking mind. I should never have paid attention to this. This is insane, no? I think that I should open a picture and have it look the same when I open it in two different image viewers. That's actually crazy. Oh my god. Maybe color profiles were missing. Oh my god. But like, are any of these guys even using color profiles? Like, what the fuck is going on? What the fuck is happening? The embedded color profile is probably messing things up. Yeah. I guess we did see that there was one in there. So when we extracted the frames with FFmpeg, it was probably doing something. Wait, now, these are different, right? Am I crazy? Let me triple check here. They're definitely different, right? This one you can't see the backpack edges on Chrome, but you can kind of on Firefox. It's definitely like subtly different. This is insane. This is crazy. Chrome is darker, yeah, okay, I agree. But also like kind of more washed out at the same time. That's crazy. Okay. Jesus Christ. Sorry, I'm trying to think about what the next thing to do here is. I think what I want to do is like prove to myself that we need to just like prove each part of the transformation, right? So can we programmatically generate an image that we think will just have like equal steps of increasing brightness to our human eyes, right? and load that and make sure that it looks the way we expect at each point in the pipeline. That seems reasonable to me. So like, can we with Python? So okay, first of all, let's look up some image specs. PNGs, right? Like PNG, linear sRG, like, or linear. Can we ask PNGs to be linear? Maybe we can ask. I think that you can ask BMPs to be linear. What does? Okay, let's check. What does STB image support? He supports. Oh, he supports our favorite PPMs. PPMs are so simple because we can kind of force things to behave. We can just like literally write the binary out. So maybe we start there. And I believe in PPM image format, we can specify whether or not the color space is sRGB or linear. I believe. PPM and PPM documentation defines that gray color values use this and gamma transfer. However, depending on the application, the used color space may be sRGB linear or some other color space. There is no metadata. Oh, kill me. Never mind. Any 8-bit format has some encoding because if you save it in linear, it creates banding when you convert to sRGB. Makes sense. Makes sense. So is BT709 different than sRGB? Yes, right? Yeah, because they're saying it might be different. BT709 versus sRGB. BT709 is the transfer function of sRGB. I see. So they encode the same color format, like the same colors, but sRGB has like some extra shit on top of it. But different their gamma curves intend to use. So interesting. sRGB was created after the early development of 709. The creators of sRGB chose to use the same primaries in white point, but changed the tone response curve to better suit intended use in offices in brighter conditions than television viewing in dark living room. They share the same primary chromaticities and white point. However, sRGB is explicitly output referred with an equivalent gamma of 2.2. Display P3 uses sRGB EOTF with its linear segment. A change of that segment from 709 is needed by either adding parametric curve encoding of ICV4 or by using slope limit. Oh, okay. So does that mean Rec 709 does not gamma curve? They have these primaries. Okay, the coordinates are proportional. The physical intensity of each primary, namely emitted, receive power, blah, blah, blah. So they do this, which is different than the sRGB encoding. I think BT709 might have different gamma. Yeah, it does look like that, huh? Okay, let's go back to PNGs. As an aside, I don't think OpenGL specifies if hardware-assisted sRGB handling happens before or after blending. It does suggest that it be done after, and I think most, at least modern hardware, is safe enough to do that. In any case, you're right. The only way to potentially get the right thing without thinking that... Oh, you're saying... you're responding to this guy. If... Wait. Where is the message you're responding to? Can I click that? No. I only have if you don't. If you don't, if you don't, if you don't, if you don't. Here. Oh, so you're talking about this again. Okay. Jesus Christ. It converts before blending, otherwise pre-multiply alpha if it don't work. Jesus Christ, dude. It just every day, Every day this gets harder. Every day I look more and I'm like, this is worse than I thought. Okay, so PNG supports palettes or RGBA. Blah blah blah. Does he talk about if the PNG specifies like its gamma curve? Like, what do the RGB mean? Oh, here. Ancillary chunks. So we can use the sRGB ancillary chunk to say you should be sRGB. What if you don't do that? Okay. So if I generate an image with PIL, pillow generate sRGB PNG. Is that like a thing that happens? Great question. I see. So you can specify an ICC profile if you want. So there's like tags on ims.save. PIL image. Docs. API docs. On image, we have save. And params are extra parameters to the image writer. Kill me. Kill me, kill me, kill me, kill me. Okay, here we go. Opening may set the following info. Saving. Here we go. Okay. Quality. Is this only JPEG or what? Yeah, this is JPEG. Can we look for PNG? Here we go. Saving. So we can provide transparency, DPI, PNG info, compress level, ICC profile. Okay. I don't. Okay, what would this guy fucking say somewhere that you could just write ICC profile equals what? Was this in here somewhere? This guy said, oh, I see. He's pulling it from image CMS. Okay. So I guess no tag on a PNG probably means linear? Jesus Christ, I want to shoot myself. This is crazy difficult, man. Okay. What is the color space of a default PNG? Like, is interpreted as sRGB. Okay. What about the sRGB ancillary data chunk? Okay. Oh, I see. We get to throw some extra shit on there, I guess. Okay. So now the question becomes, if I save a PNG with PIL constructed from some image data, I guess it's probably assuming that what I make is also sRGB. I guess. From PIL import image. From import numpy as numpy. And can we just do something like, I don't fucking know, man. I want to do something where we create a image with vertical bands. So can we do like numpy array d type is equal to can we do like zeros? Shape of, I don't know, 256 by 256 by 3. D type is numpy uint 8. I want to do something like image data from I don't know, like uh 0 to, can we chunk it like 4 x in range 0 to 4 256 jump by 256 over 4. Probably easier this way. For x in range 0 to 4, image data, so this is probably yx, so everything x to x time, I guess like start is gonna be 256 times x over 4, and equals start plus, I guess it's more like x times 256 over 4, and then start is plus 256 over 4, and then we go like start and everything is equal to like chunk, I guess. I guess let's just start. And maybe we do more. So like num bands is 8 or something. Something like this. So, and we want them to be monotonically increasing in perceived brightness, so we need each one to double, actually. So how do we do that? Fuck my life. Well, let's start like this, and we will assume that if this thing is sRGB encoded, and we do like an image from array image data save like bands PNG or something. Oh my god. I thought we did this already, but I guess we left that environment. What? What am I doing wrong? What am I doing wrong? I thought that worked. I thought this worked. That works. It's this doesn't. Are these not ints? Is that why? Might be something like this. There we go. Okay. So if we actually open bands, I don't know what I was expecting to see here. I don't really know what I was expecting to see here. So everything's so hard. My gut says that we're getting from dark to light way too fast here. If we wanted like monotonically increasing, we want each one to double in linear. So it should be like 1, 2, 4, 8, 16, 32, 64, 122, 56. So if we want 8, this is 1, 2, 3, 5, 6, 7, 8. let's just do this. Val equals 2. And then we'll say equals val, and val times equals 2 or something. I don't really know what I'm going for here. I'm just trying to... Wait, what's he mad at now? Oh. -1 here, I guess. I don't know what I'm trying to do. I don't know what this is supposed to prove to me, to be honest. This is too quantized, make a smooth gradient be clearer. Yeah, maybe that's fair. We literally just go 0 to 256, and we don't band it. We just go, like, little smooth. That seems reasonable. So can we do... NP range... What? How do you do this? You, like, range and numpy arrange. Start, stop, end. 0 to 56. D type is np uint 8. Image row. And then we need to, like, numpy dupe, like, duplicate along axis or something. Repeat. Image row RGB is repeat. Image row number of repetitions, so 3. And axis is 1, probably. I think. Oopsies, that's not what I was trying to do. He doesn't like this. Okay. I guess here you can just, like, you go 0, 0, 0, 1, 1, 1, 2, 2, 2, and then you repeat, I guess here you do, like, reshape 256 by 3 or something. There we go. So now we see... no. Oh, maybe that is right. And then we want to repeat this. I'm not really sure. Image row RGB. We want to repeat this 256 times along, like, the 0th axis or something. I don't really know what's happening, man. I don't know. This seems like it might make what I want. Can we print, like, the first row of this thing? Nope, that's not what I'm doing. That's not what I want. Repeat on axis 1. This is... Fuck off, man. Okay, here... Okay, we'll do it the stupid way because I'm too fucking stupid. We zero it out. We just create our thing. And for 0 to 256, we say image data at this x value is equal to x. Fine. Okay, here we go. Nice. Okay, so this is if we do it linear. So this means that PIL, we are outputting the sRGB curve directly, right? Because we're seeing, like, if we want to see this kind of like monotonically increment, we would do something like import math pow x 1 over 2.2, right? No? Oh, fuck. This is 256. So we need to do x out of 256 times 256. Something like that. Other way? There we go. So this is what we wanted it to look like. So this means that the Python library is not converting to sRGB before saving the PNG. Yeah, like it's just taking what we give it directly. Right? So now we have a good idea that we have an image here that is sRGB encoded. And so can I copy bands PNG into samples? And if I run MPV, okay, if we run MPV on this thing, which I think we've lost the terminal that has MPV available to it. Oh, because we've been jumping around terminals, I see. Okay. MPV samples bands. Okay, so this also looks about right. Right, we're seeing this guy monotonically increase. Now, when we apply our profile, like, does that also look okay? Right, like, does this and this now look the same, I think? Yeah, these look identical. And if we run MPV with and without the profile as well, right, like these also look the same. Like there's literally no difference between these two. Alt-tabbing, you can't even tell I'm alt-tabbing because they're exactly the same. So that's interesting as well, right? All of that kind of indicates that where it gets interesting is probably due to the embedded ICC profile that FFmpeg spat out. Right? So it's possible that our replay file has an embedded profile in it generated from OBS for some reason. Maybe? Can we like... Fuck off. Ah! Everything is so fucking hard. Okay. So... some experiments. Let's put this up here. So, generating a gamma 2.2 image with PIL manually looks the same everywhere. Ish. Everywhere-ish. Which PIL is taking data and assuming it's sRGB encoded before writing. Smile. Okay. Now, MPV looks different on our replay file when gamma 1.0 profile is applied, but not on the sRGB image. Okay, well then, I also want to check. We have like other ICC profiles we compare it with, right? So we can look at the like 0.55 gamma ICC profile? And does this look the same as like the 1.5 G ICC profile? Like, yes? So that's even more confusing? If you press I, do primaries gamma stay the same? Yeah, okay, so note that 0.55 gamma and 1.45 gamma also look the same. Surely profile is just broken. Right? Surely. We have something in the history where we had like verbose message display level all. Like, what the fuck? Ah! Maybe it doesn't apply profile if there's no embedded profile or something. Opening profile. I'm so confused. I'm so confused. Okay. If we open up our thing. If we open up our thing. This is what we expect to see, right? As we adjust gamma, kind of like the center point of this image kind of moves left and right. So let's generate a profile that like really fucks our shit up, right? 0.19 gamma. That's what we expect this to look like in MPV after. Okay, wait, that's promising in some way. It's not perfect, but that is interesting. Let's do like 0.8, 0.75. You know what? That is a very, very, very good sign, right? So when we have a default default image, we generate our profile. Our image isn't trying to do any color correction of its own. This looks like very good, right? Like the banding's a little different, but like clearly MPV is applying a profile that is doing what we expect. That is very promising. The gamma part of it is working for sure. Yeah. So then I believe that the problem probably is related to like the embedded color profile of the PNG, which surely STB image is just not respecting, right? Like surely if we have an image with an embedded color profile, STB image is not going to be doing anything with that, right? Because he would have to have some sort of like color management library to do the conversion, right? So STB image is probably just giving us like the pixels as is, and we're supposed to interpret them. So can we force the default color space when we extract? I bet it's something like we extract the frames with FFmpeg. Well, hold on. So when we use the default sRGB profile, well, okay, let's use our GUI to generate a 1.0 gamma profile because we believe that ours is working to some extent with MPV there. Then with MPV, we play this thing, and it still looks normal, right? Perfect. Now, can we play the original replay file? Okay. Which is making this dark as shit. I want to, like, strip. Can I, like, hold on. Somebody told me to press I in MPV. So the input color space of this is, he has like a primary is BT709, transfer BT1886, color matrix BT709. Like, I don't really understand what any of this means. Okay. Let's start for a second with asking ffmpeg extract sRGB frames from video. Can we do that instead? Maybe this is an idiot question. How do I extract 1 frame per second from MPV or from a video with ffmpeg as an sRGB encoded PNG? Okay. So this guy's saying, yo, make sure that you're using BT709 everywhere. Export format sRGB. Okay. So if we do this, streamer replay. This should at least remove some aspects of confusion. Output sRGB. Output files invalid argument. Why? Unable to pass option value sRGB. I see. FFmpeg video filter format. Filters docs. Okay, I hate it when it moves when I click it. Format. Oh, we'll just tell this is wrong, right? Oh. Maybe we do this. We'll try this one. We're not gonna think too hard about it. Option not found. Option not found. I guess we'll just slap this in here. Oopsies. Wrong line, wrong line, wrong line. Oops. Edit. Send. Blah, 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 blah. Everything's too hard. Okay, this is not helping. This is not helping. I want ffmpeg. So he's given us some clues. We have format, color space. Can we just start here? Okay, so there is a color space thing. And we can do specify the output color space TRC, primaries, range, format. So just sRGB isn't one of these, right? But sRGB, like BT709 is like pretty close, right? So I think he's just throwing some extra shit in there that he doesn't need to, right? We just go like this. Yeah, that seems a little better. TRC has an sRGB option? Yeah, true. True. I don't know, man. I don't really know what I'm trying to do here. I'm just trying to like reduce complication through everything. Someone's linking me something. Yeah, this is I'm asking more for him to like not fuck my shit up. Like the frames that he posted last time had an embedded color profile, which like this one does too. Right? And I'm trying to like get that shit out of there. If that makes sense. If that makes sense. FFmpeg PNG without embedded color profile. Blah blah blah. Okay. Jesus Christ. Everything's so hard. Extract PNG from video Linux. They're all gonna tell me to use FFmpeg, right? They're all gonna tell me to use FFmpeg. You could just use ImageMagick and specify color space sRGB there to convert. Maybe. I mean, then we're relying on ImageMagick to do the right conversion. But at least from our perspective of our color management shit, it removes some confusion. That's one more step to fuck shit up, I agree. But it helps us diagnose if we're fucking shit up in our pipeline. Maybe? It's crazy. It's crazy that just like opening an image is so hard. I mean, the other answer here is maybe like using STB image to load our picture is now maybe looking like the wrong answer, right? Like we need something like advanced enough that loads like something that loads the embedded profile, right? Right? Yeah, ideally we get something that just gives us a fucking bitmap in either like in a defined space so that we know what to do in our shaders. Yeah. Does like libpng do that? Like certainly not, right? The gradient file you generate with PIL should be very good for that. But the gradient file I generate with PIL doesn't have an embedded profile, right? And it's like these images that I have from somewhere else do, and I just feel like that's confusing. Like, oh, also, hold on, brain farting again. I don't know what I'm trying to say here. If like we think I guess what one thing we could try to prove right now is if in our shader we are working with sRGB space or not. Which we could maybe do by trying to do something clever, like divide the value we get from this by 2. Right? And so now this thing should look like this. And we can compare how this looks if we divide by 2 in linear or sRGB space or something. Is that crazy? So in test 4, we can do image data 2. Here, we say bands halved, and image data 2 here. And then for image data 2, we use x over 2 here, right? And I guess image data 2 post sRGB, we can test like this, right? So we have 2 options here, right? One is that we do the division in linear space. One is that we do the division in sRGB space, and we see which one looks more like what we're doing. I think that's right. Okay. So if I open XGB open, do we trust XGG? Yeah, sure. Okay. So here, if we have all of the colors in linear space, it looks like this. But if we have all the colors in sRGB space, it looks like this. So this should prove to us like, which one does this look more like? Looks like you're working in linear space? To me, it looks like we're working in sRGB space, no? Because the halved version without sRGB, this, let me just double check that I got these right. So we have, if we do, so we have like a linear thing here, our x input. If we divide by 2 before applying the sRGB curve, it looks like mostly dark, right? Then if we do it post sRGB, it looks like a smooth gradient again, which is to me how our app looks. Right? Our app looks fairly linear, not like super dark. So this, no, you're just saying no, but I mean, but like, am I crazy? Like, if I have after applying the gamma curve, it looks like this. Which part is no? I disagree. It looks closer to linear. Oh, I see what you're saying. You just think that it looks close to the other one. Wait, let's check. So to me, the big thing with the linear one is like the left side is like very black, where in the sRGB one, like, I guess on the sRGB one, I feel like it's light more. Oh, you know what? Maybe you're right, and I'm comparing to like its surroundings in a way that isn't fair. Let's add more. Yeah, no, you're right. Like, if I look at it here, it looks very different from this. Like, extremely different. Oh, oops. Wrong picture. That'd be why. So this is Yeah, I could be on your side. That it looks more linear than sRGB. I agree. Which is okay now. How? 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 Right? Because like I do not think like we are not doing any of that sRGB stuff in here. We didn't specify anything. So what the fuck? I mean, the other thing we can do here, by the way, as like another test, is in our shader, we can output the values manually, right? Just fuck sampling from the texture. And we can just do like vec2, we can do uvx times, I guess it's like float val is uv.x over 2.0. And then shove this in vec4 val 1.0 or something, right? And this Jesus Christ, that's confusing. Hold on. So this indicates that our output of the fragment shader is sRGB, right? Because if we want this thing to look linearly increasing, we do how this 2.2, 1 over. No, other way. Hmm. Also, am I fucking confused about like perceptual change in some way? Um, like this is gamma 2.2, right? So here I've just manually taken the x coordinate of this thing and applied 2.2 gamma to it, which looks like this, which is what my monitor is doing. Oh, so the sRGB encoding opposites it, which makes it linear or something. Oh, ow, 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 ow. My head. What's it supposed to look like? Do I have everything backwards? I might have everything backwards. What is currently on the screen is non-linear. Yeah, I think you might be right. It looks linear to me. But that's because my perception is logarithmic? Oh, we might have to do all these tests again, right? Like this. What you just said is correct. So, what I actually want to prove if everything's linear, like this is what the linear version looks like, which means that the shader output is linear. And then going back to the pillow example, the thing that we generated, we think the output's linear, good, and so we apply a gamma 2.2 curve to make it look linear to us in linear space. Fuck, that's confusing. Right, okay. So, we apply gamma 2.2 in a... No, wait, I'm confused again. So going back to this guy, and can we not do any of this 2.2 shit? Okay. Okay, let's do this. Hold on. Oopsies, wrong fucking thing. XGG open, bands, PNG. Okay, so this is the linear version. Here is what the halved version of that linear thing should look like. And I guess if we were working in sRGB space, it would be like... you would apply 2.2, then apply the inverse of this thing. Oh my god. Yeah, it would be like something like this. Okay. I think this is true. So bands have sRGB. So if we are working in sRGB space, it would look like this. And if we were looking in linear space, it would look like this. Okay. I think that's true. Okay. And there's just like two... Okay. I mean, I think it looks kind of like this, right? No, I guess it is neither. It could be this one. Can I make... Checking the math again? Okay. Give me a sec. Okay. So, we think that this should be the same. If this is linear output... Hold on. Oh, it's the wrong fucking, hold on. It's the wrong fucking picture. Hold on. Hold on. We fucked something up. We fucked something up. Hold on. We were using an old version of the band's picture. So now it should be the right one. Which to me is matching the linear one. Like, can everyone agree these look the same? Do we all agree that these are the same? It's hard to tell because their surroundings are different, but to me, these look like the same picture. I think. Right looks darker black. Not the same. Yeah, in my eyes, also, right might look like a little brighter. Here we can overlay them like this. Yeah, clearly not the same. Clearly not the same. But very clearly not this. But you lost me somewhere along the way. Yeah, that's fair. Okay. So in test 4 PY, we output a linear image. I think. That... Oh, fuck. No, everything hurts. Everything hurts. Everything hurts. We output monotonically increasing values linear that we think get saved directly as sRGB? I can't remember anymore. No, we applied a gamma 2.2 curve originally, and we saw it looked linear, which meant that the output of the PNG was linear. I'm confused again. I'm fucking confused again. Sorry, my brain is like actually fucking melting. Okay. So, if we do this, POW X 2.2. Oopsies. Wait, what's he mad about? Oh, X over 256. Oh, 256. This looks like a nice, smooth gradient. Which we think means the PNG we are saving with Pillow is linear. Right? Because our human perception is non-linear. So that means that if we generate this thing and maybe open it with GIMP, like, I don't really know what we expect to fucking see here. Like, if I color pick this thing, in the center, like, what is this giving me? Like, something way below, right? So, which makes sense because we perceive changes in darkness more. So then over here, we should see something around 0.5. Yep. Okay, versus if we output linear values in here, no curving, open it in GIMP, it looks like this, right? Super weighted towards the left. I sample in the center. This will give us a value close to 0.5, right? What now I'm confused about is what the fuck any of that means. Right? Like, I don't... I don't have like a clear understanding anymore of like, oh, I mean, yeah, here he's saying profile sRGB here. I just don't know what that means either. Fuck, man. Linearly increasing values interpreted as sRGB should look linear perceptually. Let me think. In my gut, something says. Okay. Wait, hold on. Hold. I think that's true. But in my head, uh, why do I think the opposite? So linear increasing should look linear perceptually. So okay, but don't these two statements conflict? Like, I have to apply a 2.2 curve to make it look reasonable to me, right? So for me to see something that looks linear, I'm doing this essentially, right? Or like some version of this. And my understanding was that sRG, like the display should be doing this, and sRGB is encoding this. That was my understanding. So I would have thought that your display is the one that applying that curve. This curve, yes. The image itself should. Oh, okay. So you're saying if my image sees this, the thing that the display is getting is this. Then the display itself will output this? No. Yes. Right. And so that's why if we want actual linear values, we do this, which will look not linear to us. And so if we apply linear values and they look non-linear to us, that means PIL, as part of its encoding process, is doing this, because then this will offset and it will look linear to us at the very end of the pipeline. Yes. Okay. So I don't really trust any of our experiments anymore because I think I was confused. So PIL given linearly increasing values does not look linear to my eyes. This means PIL is sRGB encoding. Because linear values with the display sRGB curve should look linear to our eyes, who are logarithmic. Since it doesn't, let me double check this again. Since it doesn't, PIL must be applying the inverse display curve to create a linear signal at the end, which does not look linear to my eyes. Holy fuck. Okay. Am I like, I can't tell if I'm like fucking stupid or if this is actually just fucking hard. Cause like, it seems like it feels so complex just to break down like every individual component. Thank you, chatters. Seriously. Okay. So we now know that we have an sRGB encoded PNG. And I guess all we have to do now to prove what so now all we have to do to prove what STB image is doing is literally just open this fucking file with STB image, right? And see what it does. And if it's linear or nonlinear, that will give us some really good clues, I think. So can we go to GUI Zig and after we load a sample, maybe we can go like 0 to width. Can we look at image I times 4 or something? And maybe we also have to put the right sample in there. Okay. And then we should also write down like the name. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this means STB image is getting the linear data back. Right? Right. So STB image gets the values we wrote directly into PIL's image buffer, which we think means STB image must be un-sRGBing the data, must be like linearizing the data. There's another option here where STB, where like the data is linearized in the PNG and it's flagged that it's linear. But I think that this is true. Can we confirm this by looking at STB image? Load open. STBI load from file, load main. If it was linear in the PNG, you'd see a bunch of banding. True, huh? Which I don't think you really see. So you agree that you think STB is undoing the encoding, but I would like to prove that to myself. So if we are in main, if ndef no HDR, so we have not defined no HDR, which means that we are in this. If HDR test, which is probably this, right? We're probably not HDR. And then if data, LDR to HDR. Okay. So load main. He does a PNG load here. and do PNG here. He is looking at parse PNG. This is like the header probably. Um, uh, P must be the PNG here. So his PNG image out here. So his parse PNG file into P is probably the interesting part here. He hmm hmm not clear. Not clear, but it does feel like it would be nicer if I could prove this, but I might be too fucking stupid. There's this like, oh, here we go. So he does apply if not defined, no linear. Yeah, so he always does LDR to HDR, which is confusing. And in here he's applying some like gamma scale. Shouldn't he only do this on HDR files? Confusing. But he is doing a little gamma here, which is 2.2. So this looks like he's just going like, okay, we're applying 2.2 no matter what. Which I think is confusing because that's not really, I guess in floating point, it's like something along the lines of like, sRGB is like kind of like gamma 2.2, but they fuck up the gamma 2.2 so that it like truncates better into 16-bit, but they're working with floating points, so they don't really give a fuck or something. And then I guess that means that all data they kind of okay. Okay. Yeah, it does agree. I do agree that at least our experiments and that code all kind of line up to say that the data is linearized before we get it. And then all of our OpenGL stuff is working in linear space. Okay. And MPV with no embedded with on files with no embedded profile looks the way we manufactured. Right? So now the only real confusion is when there is an embedded color profile in the video, we suspect that we will load that thing as if it was sRGB in our GUI. But MPV will do the correct color conversion, which means that it is impossible for our thing to look the same as what MPV will play, right? So MPV will update or will handle color transformations based off the input profile. We will not. So what we really want to do here for testing is we want to ensure that we're back to the idea that FFmpeg needs to output like actual sRGB images. Right? So which I believe this BT709 color space thing kind of did for us. We can also confirm this where we have in here we have 316291. Wait, was it 316291? 31 62 91. And we want to copy these guys and bring them into our samples and see if they look different. Oopsies. Oh, oops. Hold on. Our shader is dividing by 2 now, which was a temporary experiment. So the next question is, do these two images look the same? And I think they do, right? It's really hard to tell. Save. Save. Which I know we're introducing more ways for shit to get fucked. But what I'm taking from all this is sometimes it's just better to change the monitor settings. Yeah. Like, to me, these look identical. Identical enough. Like, I don't see, like, any major differences between these. Which kind of seems to me like I don't know what I want to do with that information. Oh, what we can do now, though, is we can save our profile and test loading both of those PNGs with MPV and see if there's a difference, right? So we can do MPV profile, ICC profile is out.icc, and we should look at samples frame 91, which is clearly fucked up. But if we also look at, like, so now we're back in MPV land, and MPV is fucking both of these guys up equally. Which is also interesting. So and I'm just gonna confirm to myself visually, which you guys can't see. I just want to apply this fucking gamma curve again, like here in my monitor, just because I need to like solidify the current state in my head. So if I open this up, no profile here, it looks fucked. And then I bring this back to none. Yeah, okay. Okay, so you guys couldn't see that, but when I open this thing, the normal picture, then apply my output file to my monitor, it looks the same as when I apply it with MPV in the other case. I think. Wait, let me just go one more time. I can't like screenshot and compare, but it's really fucking dark. Like, really fucking, like, okay, what we need to do is we need to open another MPV with the ICC profile, and then I need to look at this one, then quickly unapply and flip back to this one. Yeah, they look the same. Okay, so the good news is applying color profile in MPV and on my monitor are consistent with each other, but not with my GUI. So this is more confusing, right? Because this means MPV and the GUI are consistent with each other with no profile applied. Then applying a default sRGB profile is fucking up the picture in MPV. Only on images with a profile attached to them. What happens if I strip that metadata? Right? So we can try to strip the data by going test 5pi or something from PIL import image, import numpy as np, and can we do something that's just like image open samples 91, and then discard all metadata associated with this thing, right? So we convert this to I think it's like RGB or something, and then we get the we convert this to an array. Okay. Oh my god. Nix shell Python 3 packages pillow and Python 3 packages numpy. I must be in like yet another terminal. Okay, so this looks like reasonable RGB data. And then we we say convert this thing back into an image and just save this as samples 091 stripped. And now the question is are we consistent on that bad boy? Like, first of all, when I open this in my GUI, which one was 91? It's the one with the cabinets, I think, right? Yeah, so we have 3 with the cabinets, which to me all look the same. Okay? Then that's a really good sign. That's a good sign. So if we strip the data, MPV now agrees with us when we apply our curve. Does he agree with us when you don't? Yes. Okay, and then I go in here and into my thing. First of all, let's remove this fucking print first line bullshit. Okay. So in here, we then apply a curve. Let's apply a gamma curve. So let's take this thing and try to make it look like this. Hit save. Then we open MPV with our profile. Okay, fuck yes. Fuck yes, dude. Fuck yes. Tell me that's not the fucking same. I mean, it's fucking close enough. I mean, it's not perfect, but that's pretty damn close. There's like a little bit of like saturation difference. Okay? So, there is a problem in the pipeline somewhere where if there is a color profile in the thing we're looking at, MPV is now applying a transformation that we don't like. Because our application is not applying the profile. Yes. Yes. Okay, so the bug is our app does not respect color profiles. I'm pretty sure that's the only fucking problem. I think. I mean, the other bug is we also don't respect monitor profile. So the preview is only valid when we have nothing applied on the monitor. But I think that makes sense. I think that makes sense. So for us to have a preview that will do what we want it to do, that is like relevant, we either have to ensure that any image that we feed into this program has no color data associated with it, or we have to respect it. One of the two. Holy fuck. Oopsies. I didn't mean to do that. I looked at the PLL code. It doesn't look like it's transforming the image values. It looks more like the PNG is missing the sRGB chunk, which leads image viewers to interpret it as linear. That's kind of what I was thinking at first. Psycode was kind of saying that I would see banding in the data if that was true. But I could see that kind of going either way. While text incoming, I think everything you're doing is correct. The problem is that your program is operating different than the ICC world profile would. By the time you're applying the ICC profile, the game operator has already done the color conversion, so the output you get into the ICC is already in sRGB, whereas your app is reading linear data as input. Yes. So I already intentionally am accounting for that. When I generate my ICC profile, I am regenerating the inverse curve. I'm kind of like, I am going in my app. I am doing like, apply my transformation. So like my gamma, right? Then I am applying the like monitor profile curve, but with the X input to this, instead of being linear, the X input to this is this guy, if that makes sense. So it's like a double, it turns into like out is, great, yeah, I got it. Okay, cool. You understand. Yeah, it's like out is like essentially gamma 2.2 over like my change is like kind of what's supposed to be. Yeah, okay. I think I'm pretty confident on the bug. Pretty confident on the bug is that we need to respect color profiles for the preview to look correct. And then there might be some like additional shit going on here. Like we haven't really resolved the idea that the way that MPV was getting too dark before. Apparently sRGB is not exactly gamma 2.2. Yeah. Agreed. The small differences could be. Oh, right. You're saying you're linking an STB issue, so you're probably saying STB applies gamma 2.2, which is like approximately correct, but not exactly correct because of the like 16-bit shit at the bottom. Yeah, understood. So it could be that. But yeah, I don't need mine to be perfect. I just want it to be relatively close. Okay. I don't know what the takeaway is here. I think the takeaway is that we're almost correct. We are like so close to correct. And maybe we are correct. And we just have to make sure we strip profile data or apply it. Yeah. Okay. I'll think about it. My head hurts so much. I am down to do 30 minutes of Arc Raiders. Let's just play some fucking video games. My head hurts too much. For those of you who only care about coding, thanks for watching. We'll be back. I might skip tomorrow because I'm going out with friends tonight, but we'll see. Maybe tomorrow I'll be on, maybe not. Definitely Sunday though. So if you don't want to watch video games, see ya Sunday, maybe tomorrow, and if not, I just need to. Brain is fried. Video game time. Smile. And Arc Raiders, baby. Arc Raiders, baby. I think I have to turn off my screen capture while I open Steam because it will just like leak all of my friends' legal names. Which I think the part of the trick here is that I need to remove my friends' legal names from the nicknames on Steam. That's really like the big thing that's got to get done here. Anyways, we're validating some Arc Raiders. He's working hard. I guess maybe it needs to update because I have the game installed twice, once per account, which is kind of funny. But hopefully it doesn't have to do a big update. If it does, we'll just give up in one stream. But maybe he's just downloading some nice little pre-compiled Vulkan shaders for us. That'd be kind of hype. That'd be kind of cool. Wouldn't it? It's funny how much we have to think and learn for something as simple as like make game brighter. Oh no, starting download. How long we thinking? He's just validating again. What is bro doing? I just want to play. Okay, we'll set a cap. We'll set a cap on a few minutes. Yeah, it's crazy. It's crazy how much just like depth there is to like every problem. And I kind of agree with Mr. Psycho when he was like, it's not that complicated, there's just a lot of transformations. I think like one of the hardest parts, I think like the thing that's always given me the most struggle in probably like every programming, like across all of programming, is like coordinate spaces and coordinate transforms. Right? Like in 3D, this was always so hard for me, right? Like you'll do things like you'll switch from left hand to right hand, you'll like be from this guy's perspective or that guy's perspective, and like all of the bugs, like I feel like I write so many bugs that are just like I can't keep track of all of the coordinate spaces in my head. And I don't know if I'm just like managing them poorly or like I just have a poor understanding of it, or if it's just hard for like human brains to keep that many contexts. Like I don't know if like I'm the problem or coordinate spaces are the problem. It's all so hard. Tell us one of your unhinged stories. Dude, they're normal. None of my stories are unhinged. My life is a normal life. When I'm like, I drank so much hot sauce I took off my shirt and lay on the parking lot ground till my mom picked me up when I was in school and then vomited an ice cream bucket full of red stuff. It's like, that's normal. We all did that. It's a very big chain of things that need to happen in a very precise way, and you fuck up one of the links, you're fucked, which is why I think it's common to see even browsers doing it. Can't make sense. Dude, when we fucking opened Chrome, Firefox, when we opened up all those image editors, and like, there were like 3 different pictures, it's like, fucking kill me, man. Fucking kill me. Oh, hold on, gotta change my monitor settings so I'll be able to see when I play the game. Dude, I fed so much yesterday. I fed like, dude, it was bad. It was bad. What is it? We lost 1, 2, 3, 4, 5, and then like down here we lost like 1, 2, 3, 4, 5, 6 in a row. I was just telling Robo not to be too confident, and then you hit him with that. Yeah. Okay. Okay, a couple raids. What's on right now? Cold Snap, Night Raid. Cold Snap, Buried City. Let's do that. Let's do that, and let's do one of these guys. Maybe one of these guys. Maybe one of these. One of these. Is that the right one? I feel like the game's really loud. I don't know if it feels really loud for you guys, but it feels really loud for me. And we need some ammo, of course, and some band-aids, and some shields, which I think I have to buy.
It's true that I can't taste
some stims. We gotta take some drugs and maybe some backup band-aids. Boom, 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 and let's get crazy. Let's get crazy. Dude, I gotta make some money back. We gotta focus up, lock in. Lock in. No feeding money allowed. And then we gotta focus. No music allowed either. We gotta focus the fuck up. Yeah, I mean, that does look really loud still, huh? Like, yeah, I'm gonna turn the game down a little bit when we get in. I can only tell by the bars on my screen, but I think it's like too much. I like how every single video game I play, I don't know what it is, but like every game I play it like 5% volume. I don't know what it is, but like, to me, 5% right now sounds like about right. Where like videos, they're not like that. I don't know like why every game is so fucking loud, but it is what it is. Okay, we gotta collect some plants. Always gotta collect some plants for our green band-aids. Charbit, thanks for the prime. Much appreciated. Alright. You gotta collect some plants. And this is also a good distraction, because otherwise I'll just run in and feed. But this gives me something to do while we wait to hear bullets. I'm hearing bullets. One more plant. Gonna continue working on my pile time execution. Good luck with the game. See y'all tomorrow. Later. Thanks for all the help today. Alright. What were we hearing? Oh. What are we looking at? What are we looking at? Well, that clears things up. Oh, fuck. Don't look at me. Don't look at me. No. Don't look. Don't look, sir. Oh, he's coming. No choice. Well, there goes my cover. So one guy died kind of like down here somewhere. And then one guy is... Oh. He's like right in front of me, right? Like that's got to be on the roof with me, right? Where the fuck is that? Oh, There's another guy! No! Hard life. Hard life. I don't know what I'm supposed to do there. I think that I just have to not be in that position, because I think I'm guaranteed dead. I guess I could drop, like, down, maybe? But I just have to not get shot in the back there, I think is the answer. I think... let's do this. Let's do this. And this. I obviously need to not feed my good shit again. We're gonna lose too much money. Let's take a few of these. We're going cheap. We're cheap people right now. Yep. Yep. Missing ammo. Fuck you. The plan is to bum rush someone, take their gear. And not get shot in the back on a roof. No getting shot in the back on a roof this time. Do you guys like my rubber duck situation? We're getting pretty close. I'm trying to get them so they have to stack on top of each other. So I need to get like maybe another couple hundred. But we'll get them. We'll get them. Alright. Oh, good news. We spawned next to a sick loot room. Bad news, I die every time I go there. So, we got a little bit of the 1-2. There's this, like, my friends call this room Death Room. Because there's, like, one way in, and if you're not the first guy there, you're just guaranteed dead. But the good news is that we probably are the first guys there, and so maybe we can guarantee dead someone else. Maybe. Maybe. We will see. Sure. Sure. Yup. Band-aids, need those. Metal, yes please. And durable cloth, always could use more of that. 4 band-aids, we're fucking chilling. No gun, hard life. And then we wait here for like 15 seconds to see if someone's coming. Listen. Listen. Alright. I think we're good. I think we are good. That was really close. That was a close death. We do this first. Oh. Did I kill it? What the fuck? Alright. One more loot room, and then we go kill people, I think. I think that's the play. We're listening, we're listening. I don't hear shit. Loot, loot, loot. Ooh, another blue band-aid. Love that. Another music box. Holy shit, we're rich. Duck in the safe pocket, always. Close the store. Anything good? Ooh, ammo? Yes, please. Oh my god, wait. We're so sick on heals. Metal, always. Real loot goblin game. Loot, 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 loot. Give me some loot, 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 loot. Okay, no, but don't worry. We'll fight someone. We'll fight someone. 2 of these is crazy. I mean, honestly, we could just leave now. Because I've been fucking feeding money, and this is like a 50,000 profitable run right now. And that would be like probably the right call given how my games have been going, but we have to fight. We have to fight. There's people like over here somewhere. We gotta fight. Wait, one sec. I can't stop myself from looking for a little bit of loot. Gun case. Gun case. We're rich. Alright. Now we try to get in on whatever fighting was going on over there. We feed, and then we cry. That is the plan. Alright. In here? Probably not. Probably not. If I had to guess, the fighting's always in that building. Like, 100% of the time. We go take a look. Oh, fuck! Alright, well... Oh shit, that guy's got a snap hook or something? Alright. Alright. I'll take it. I'll take it. I'll take it. There's another guy up top, I think. I'm pretty sure there's a guy in my head. Pretty sure. Or else that snitch wouldn't have called, I think. Maybe it's fine. You have a smoke? Nope. Oh. 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 Oh my god, we're fucking rich. I think that I would rather hatch, given how poor I've been recently. So I think I just leave this, and don't even loot the other guy I killed, and we just, like, Oh my god. I don't want to touch those, but it's not worth it, it's not worth it, it's not worth it, it's not worth it. This is really, oh fuck, oh fuck, I should've, oh shit, oh fuck me. Oh my god, the fuck. I thought I had more time to shoot that. Fuck my life. Fuck my life. I should have gone through the buildings. Van 4, GG. I hit the guy for 12 damage. I wonder if I could have just kept running. I don't know. If I'm on like light shields and that guy smacks me, I don't really know if there's much I can do. Okay, we're so fucking poor. We're so poor. Free loadout time. We're so poor, he says, with 3.8 million. But this is not looking good. Yeah, I don't know if I'm just dead as soon as he shoots me in the back there. Because I have to re-peek him there to just hopefully get some damage off so he doesn't, like, so to give me time to heal. But that peek got me killed. I guess the other option is try to run in a way where he won't know where I went. But I didn't have that much stamina after the 2 dodge rolls. Not sure, Pharaoh. Okay, we're gonna have to like really pull some shit out of our ass for this to be worthwhile. Maybe there'll be a gun in here. That guy's probably cheating. No, he just had a Ven 4. He just hit me 4 times with the good gun. Oh, you're saying? Oh, sorry. What's yeah? As a streamer, anybody who kills me is cheating. Sorry, I forgot. You're right. And nothing I could ever do will improve my situation. Oops, that's not good. No gun here. No gun here. Processors, music box. Shit. What's that called? Heal case. This goes here, this goes here. This comes in like this. I guess we could get cheeky and do this. Stay out of here. Your game sounds kind of weird. Like, choppy or just like bad EQ or something? Sounds normal to me, but like you never know. Alright. Oh, weird. It makes it blurry out there? What the fuck is that? Why does it do that? I've never seen that before. What the fuck? Oh, there's definitely a guy over there, though. Oh my god, that hit. That one didn't. I had to hit that third one. I think even then maybe I don't kill. That gun sucks. Or not sucks, but it's just another cheater. How much damage did it do to him? 35? I guess he had like a blue or pink shield. 35 feels low for 2 hits, but what you gonna do? We need a stitcher. Give me a stitcher on the free loadout. And then we'll still feed. The thing is, you guys will never believe me, but it's not always like this. It's not always like this. Look, sometimes it looks like this. Or sometimes it looks like that. That's not looking good. It doesn't look good if we look back in the history. I swear. I swear. All right. Stitcher? Pharaoh. Okay. Then the priority is to try to find a gun. There's like 6 gun cases over here, so surely one of them will spawn, and it will be a pistol, and then we can fight. Surely. Don't call me Shirley. Oh, I forgot about the nades last time, too. I probably could have used those. Probably could have used those. Alright. 1 weapon case on the roof. Not there. Not there. Breach room is open, so no point even checking that one. Then I think there's one over here. Over here somewhere. What's that guy doing?
A surveyor. Over there.
Not here either. I think there's 2 on the roof of the library. 2 on the loot roof of the library. Which I don't think many people check, so I think we can just... That sounds relatively close. Maybe at the, like, loot goblin building across the courtyard. Maybe. Maybe. Oh, fuck. Neither gun case here either, and I'm gonna get killed by a Rocketeer. GG. Please, God, let me in. Ow. My ankles. I want to see what's going on over there. Maybe I get a cheeky little shot. No, please, 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 please. Please, sir. Okay, well, my cover's blown. Oh, yep, that's close. Maybe I can shoot him in the face while he's looting the body? Dude, where the fuck is it? Wait, am I fucking stupid? Where's the body? Did you die to the Bastion and maybe start crawling down the stairs? Surely not. Oh, yeah, it is. Nice.
Don't shoot. Hey, don't shoot.
I need your gun, man. Oh, trigger nades. Who needs guns when you got triggers? Oh my god, wait, I'm fucking rich. Oh my god. Oh my god. We are fucking rich. Okay, do you guys want to see how real people play this game? Guns are for fucking losers and nerds. What real people play with are these super awesome things called trigger nades. Wasn't that cool and fun? Wasn't that a cool way to play the game? You don't even have to see them is the best part. You can just kind of kill them completely blind. And it's actually you're just playing the way the game is intended to be played. It's a good thing that guy had them. The colors are so good. Yeah, hell yeah. It actually has none of my color stuff applied, but hell yeah. Well, that was actually relatively successful run. Relatively, we got a few guns. We got, I think like a 70,000 free kit run is actually pretty fucking crazy. But we're pieces of shit because, oopsies, I didn't mean to press that button. Oops. Because we use the triggers. Well,
Maybe I'll call.
what you gonna do? Okay, one more. One more. And then I go walk my dog and hang out with my friends. One more. This gets, whoa. Recycled? Dude, that poor guy saying don't shoot at the end. He's like, no, please, God. And we bring maybe an anvil. And probably we need a backup shield, which I didn't mean to fucking recycle earlier, but whatever. Boom, 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 boom. And we kill a couple more guys, and then we call it. Woo-wee! Okay, refreshing the sRGB saga stuff. The only problem with what we're doing with our profile generation is that the color profiles of the input video are not respected. Right. Okay. And so I have to decide what I want to do about that tomorrow. or the next day. Which is probably, like, going accurate color management seems a little crazy. But, oh, that's a guy we can kill. We're gonna get arced, but let's just take a... Wait, I don't see the guy at all. Oh my god, and this hornet's on me. Alright, well, that blows my cover. I think chasing whatever that is stupid. We go somewhere else. We go somewhere else. Nope, we go back. He's shooting again. Was he killing those arc? Maybe? Maybe. Two deaths in there, I think. Do I see that guy anywhere? Am I cooling off or heating up here as well? Yeah, nice. Okay, we can heat up here for a second. Nope, no idea where that guy went. I also can't tell if my guy is warming up here. His suit's supposed to get, like, less snowy, but I don't think it's working, so I guess we just go. Oh. Well, I'm gonna be a piece of shit. Maybe they'll kill me, and I'll deserve it.
Hello, sir. Are you friendly? Don't like the way you're running.
Well, I deserved it.
Not happening, brother. You're not gonna interrupt me and my new friend.
You shot me first! You shot first! I was just coming over to say hi!
Oh, yeah.
I'm gonna
You
go.
didn't say hi. You were just full sprinting with your anvil out? I don't think so, buddy. You think I was born yesterday or something?
Alright. Well, that gets our Arc Raiders feeding time out of the way. Huge. And I think we call it there. I think we had a successful stream. I think we made progress. It's kind of fucking confusing, all of that color stuff, but we will live. Where's Clonk? Is it not Friday? What day is it today? Friday. No Clonk. Unbelievable. Unbelievable. Okay, we got some horror games, we got some bitching about Anthropic, we got some, I'm all gummed up is crazy. Netcode, what we got? I don't see any of, the super usual suspects on here. Alright. What is this guy doing? What are we looking at? We got Unity or Unreal. Is this C#? C++? Unreal. He's doing some Unreal C++, which is kind of fun. What else we got? Games. Multiplayer life sim netcode's pretty fun. This is Godot. Okay. What else we got? All right, let's do grooving. Let's do grooving. We'll play it safe. Go say hello. Have a good rest of your day. Have a good Friday. And I'll see you guys tomorrow or the next day. Who fucking knows? Later, Gators.